Welcome back. We're building an enterprise-grade fleet optimization system using 100% open source tools. Our pipeline solves two critical challenges that cost logistic companies billions. Number one, predictive maintenance nightmares. Unexpected breakdowns cause 15 to 20% of fleet operating costs through repairs and downtime. We'll use vehicle sensor data, engine temperature, vibration, and battery health with ML to predict failures 7 to 30 days in advance. Secondly, route optimization challenges. Poor routing wastes 15 to 25% of fleet fuel budgets. Our solution combines real-time traffic, weather data, and delivery constraints to slash fuel costs. But here's the key difference. Instead of locking you into expensive cloud services, we're building this with tools you can run anywhere, from a Raspberry Pi to a data center. Let's examine the architecture. Looking at the architecture diagram, our open source pipeline delivers production-ready capabilities through these components. Real-time data ingestion. From the vehicle telemetry, we see that we have Kafka streams from OBD-II sensors, 50 plus sensors per vehicle. We also have the location data from GPS coordinates with fast streaming processing. There can also be external data sets such as the weather or traffic APIs via Prefect workflows. The second component is the scalable data storage. In this, we see MinIO, which is S3 compatible. It acts as a raw data lake by replacing things such as Azure Data Lake. We have TimescaleDB, which is a time series data for sensor metrics. It's 20 times faster queries for our data. And we're also using PostgreSQL. It's the main relational data for vehicles and routes. When we look at the distributed processing component, we have Spark on Kubernetes for cluster-aware data transformation. We have Dask for parallel feature engineering, such as the engine health scores and the route ETA. And the other component is the machine learning life cycle. MLflow is used to track experiments and register models. We have 𝗥𝗲𝗀𝗃 for Kubernetes native model serving. We have XGBoost or LightGBM for our maintenance prediction models. The last component is the optimization and the visualization. We're using Valhalla's routing engine, which is an open source route optimization system, and we're also using Plotly Dash for our Python-powered operational dashboard. For our real-time fleet health monitoring, we're using Grafana. So if you can visualize the flow, it goes from the vehicle sensors to Kafka to Spark to TimescaleDB to MLflow to 𝗥𝗲𝗀𝗃 to Valhalla and finally to Dash. Now let's explore these open source tools and why they are dominating modern data stack. In the tools overview, we're using tools that power companies like Uber, Spotify, and Airbnb. Here's why they're enterprise ready. Apache Kafka is a distributed event streaming platform. And why it's important? Well, it handles 1 million plus messages per second. Now you compare that to your paid cloud services. In our case, we're using it as an ingestion hub for 10,000 plus vehicle sensors. The second tool is MinIO. What does it do? It's an S3 compatible object storage. Why is it trending? Well, it's 100% open source with over 56 million Docker pools. In our case, we're using it as a petabyte scale data lake on any infrastructure. The next component is the Spark and Kubernetes combo. Well, it's essentially a distributed processing on container orchestration. And this is used by 78% of enterprises according to a CNCF 2024 survey. They run Spark on K8s. In our case, we're using it for cluster scale data transformation. We have the next component, which is another combo of MLflow and Seldon Core. And its main purpose is in our end-to-end MLOps platform. And this is used by 62% of ML teams to avoid vendor locking. In our case, we can run experiments to production API in just one command. Next, we have Valhalla Routing. It's an open source routing engine, and it powers Microsoft or Bing Maps, and it has zero API costs. It provides well-optimized routes with live traffic. And our last component, Plotly Dash. And this is a Python-powered framework that replaces Power BI in tech-forward companies. Our case, it's going to give us our real-time fleet monitoring without the SaaS fees. So this stack gives you cloud scale capabilities without cloud bills or locking. Skills that are highly valued at companies like Flexport, Rivian, and UPS. We've just mapped an open source architecture that rivals proprietary system. You're learning skills that command 140 to 220K salaries in logistics tech sector. So if this adds value to your career toolkit, like this video, subscribe for more deep dives, and comment your biggest fleet data challenge below. Let's build the future of transportation open, efficient, and accessible.